Hello, welcome to the tutorial for gathering data from DesignBuilder and how to make a decision and how to choose a building from those data. Here, the main objective we are working with is to develop three different layouts of similar function. Develop a comparison among the layouts to find the best energy efficient design, and then finally experiment with the different fenestration designs alternatives to elevate the energy efficiency of the best selected layout. How you can analyze different design options and use the data from the simulation to gather around your logics and how you can take a decision on the basis of those analysis of data. To do that, we have created three different buildings, and all three different buildings had the same layout of open plan office with two offices separately for managers or higher officials, and one meeting room, and two toilets, one for female and one for male, and there is a reception. And in case of, we also made a two-story layout where we have a staircase. So if you can see that the first option we have, it's a more rectangular option, and it has a dimension of 40 meter by 25 meters. So this 25 meter by 40 meter option, as you can see in the middle, the open office, the entry is from reception areas, and you have the meeting room, two offices, and the toilets are here. If we look at the second option, building number 2, this one is much more elongated option, where the length of the building in the elongated side is 50 meters, whereas the width is 20 meters. This 50 by 20 meter building has also the same features, only the open office plan is slightly different. As you can see here, you have the reception and meeting rooms side by side, you have two offices and the two toilets on the corner, and you have the big open office area in the corner of the northeast corner. So now if we look at the two-story option we have, it needs a little time to open. So the building option 3 is two-story, and the dimension is 20 meter by 25 meter. Now in this 25 meter by 25 meter, the offices, the reception and the meeting room are in the downstairs, ground floor, and here's the building. As you can see, ground floor, the meeting room and the reception are here, then you have the office 1 and the male toilet here, and you have the staircase here. Also a part of the office, open office, is here. As you can see, we have merged the staircase zone, and we have open office on the first floor and office 2 and female toilet on the first floor. This is how we have selected all these buildings, three of the options. Now we are going to analyze the energy consumption of these three buildings to see that which layout is the best option to choose. And in case of activity, for all these three options, we have selected generic office area and also the scheduling for the occupancy we have selected the open office occupancy layout, and density is by people 0.111 people per meter square. The heating set points are set 22 degrees Celsius, and seating setback is 12 degrees Celsius. In case of cooling, we have 24 and 28 degree respectively. In case of office equipment, we have the gain of 11.77 watt per meter square, and we are following the office open office equipment layout, equipment schedule. And in case of office equipment, we have selected the open office equipment schedule. Now, in case of construction, in all three cases, we have selected the project construction template where all the default values are there, and we didn't change anything because we wanted to see that what will happen with the same type of characteristics of construction and occupancy layout in three different layouts buildings, so that we can take the decision that which one is the most efficient one. Also, in case of infiltration, we have 0.7 air change, and then in case of lighting, we have 5 watt per meter square lux. We took the schedule of open office lighting layout, lighting schedule. In case of HVAC, all of the building, entire building has the fan coil unit with district heating and cooling. And in case of heating, we have a natural gas as fuel, and the scheduling is open office heating, and the cooling is coming from electricity from the grid, and the cooling layer schedule of open office is also selected here. In all three cases, we have the same layout. If you want to know that how you can change with the schedules, you can see the previous video where we talked about how to edit and schedule. But first we will work with the default schedules here. So first we need to export all three simulation files so that we can get the energy consumption data from the simulation. So we are going to run it from January 1st to 31st January, daily and monthly annual, and we'll save all of them here. So now we have created 3 of the simulation files, IDF files, from all 3 options we have. As you can see, we have created separate folders for each of the buildings, building 1, 2 and 3, and we have extracted the simulation IDF file from the DesignBuilder file. If you see the previous videos, you can find that how to do that. The procedure is there. Now if we open the IDF files, you will see that at the end there are lots of variables, but we don't need all the variables now, so we'll just keep some of the variables that we need, and then later we'll import some other variables that we'll need to analyze. So first we reduce the number of variables. We just keep the electricity, gas, interior, and all the total facility daily data are there. We can, if we just save it, we'll do the same for other buildings too, so that it takes less time to simulate. So as we have saved all of the three options, now we can go and start the EP launch, which is the basic Energy Plus simulation platform. Here we can select the first option we have, building 1, and then we'll first, for our analysis, we can go we'll choose London Gatwick for analysis. Now after loading the London Gatwick weather file, we can just click simulate, and the simulation starts. It takes a little time. This command window is showing that if how fast or how long it's going to go for, and then it shows the run status, where this is the error one. We have 12 warnings which still the program can work with, 0 severe errors. If there is any severe errors in case of in the IDF file, the program will terminate at that one moment which line it finds the severe errors, and it will notify us. If there is no severe errors, so we can work with it now. So the variables we gave it is pretty much, if we click in the variable tab, we can see that it's the in total daily energy, and also interior equipments, electricity and lighting, and district cooling and district heating. So the options we gave it to analyze, it is showing, but one thing is it's showing in Joule, so we have to change that also into the electricity kilowatt hour, so that we can compare with each other in an effective way. So we have seen how we can do that. Now we want more variables in there. For example, we want to see that how the electricity change and how it reacts with the temperature change outside, with the variable temperature change outside, or with the temperature change, how the heating system is reacting, or with time of different times in the year, how the total system of cooling and heating is working. So for that, if we go to RDD, we will see that there are lots of outputs we can get from here. We can go for different outputs such as heat gain, solar heat gains, and other options like predictable load, thermostat, control types, water equipment zones. So we are not working with those. First we'll look for the options that we need: a site air variable temperature, hourly, and if we select that and put it in the IDF file at the end, save, and we can put that in each of the files. So we'll do it on 3 of the buildings. So this was the first one. Then we can go and select building 2, and same London Gatwick weather file. We'll put simulate, and we'll see that what the result comes up. It takes a little time. Complete. So we have 0 severe errors. That's good news. And if you open up, we will see that here also the same things are happening because we deleted the extra output variables. So if we go and click copy the site outdoor air variable temperature, open the file and go at the end and just paste the output variable and save it. We'll also open the building option 3 now and simulate. Okay, it should come up with the result very soon. The results are here. So okay, there is no severe error, and if we open the variables, hopefully yes, the results are there. The electricity, total facility in daily temperature, also the temperature is not there, we'll put it in the file. So if we go select the output and go to the IDF file, bottom, just going to paste it and save it. So now we have 3 of the building models done. We have created the IDF files. We have seen that all the IDF files are working correctly in the EP launch, and we can extract the data from there. Now what we are going to do, we'll run the simulation one more time so that we can see the different separate temperatures and also in there. But also you can see that there are other options you can get from EDD, also MDD. So these are the output files. In case of MDD outputs, you can see all the cumulative or electric equipment, all the zone wise electricity consumption, or all types of energy consumption in terms of energy transfer zone to zone, all are in there, and you can calculate those if you need to. So now we are going to simulate all 3 buildings same way, and then we'll compare the results within the 3 buildings. Also, to analyze the thermal comfort of the building in the building forms, we can also add the Fanger models or other thermal comfort models in the analysis. So first we'll go to building 1 to do that, and then we'll edit building 1 file after finding people. So we have, and as you can remember, we have to put the comma here, and then we'll put Fanger. We need to put that next all the peoples we have, so it will take a little time. So we have put the Fanger model at the end of each people object in the IDF file of the building 1. We'll do the same with building 2, and then we'll come back to do the analysis and the simulation. We have put the Fanger model at the end of each people object in all 3 buildings. Now we are going to simulate one by one, and then we'll try to get the output of the PMV and PPD. If you want to see the details of what we are doing here, you can go to the thermal comfort analysis video, a tutorial video, and you can see it there also, the same thing with a little more detail. Now we have building 1 here, and we have the weather data of London Gatwick. Let's simulate. We have 0 severe errors, good news. And before going to the variables, we will not have anything related to the PMV and PPD, because if we open the variable tab, we can see that there is no PMV or PPD data. We didn't put it in the output variable, so we'll put it in the output variables. But you can see that there is a change in the data layout. We had daily data, and when we put the hourly environment site outdoor dry bulb temperature data, it changed to hourly, and that's why all the gaps in here, because these data are coming from daily data, so every 24 hours data here, and these are hourly data. So we'll change that format so that we can have a daily dry bulb temperature and average data in there. To do that, first we have to go to the text edit file. If we go down, at the bottom we can see it said hourly. If we just put daily in there and save it and simulate again, severe error. And if you go now, see, now we have the daily data here, and all the daily facility, electricity consumption and everything is in a daily format. So we have the 365 days in there. Now we don't have any PMV or PPD data there. So to do that, first we have to go to RDD. In RDD, let's find Fanger. As we have put the Fanger model in the thermal comfort area, we can see now we have two zone thermal comfort Fanger model, PMV and PPD hourly. So if we copy that and paste that at the end here, just to see clear, we have the options here. Now if we simulate it, we should see that two options of the PMV and PPD are there. Zero severe. And if we open the variables tab now, as you can see, now we have meeting room Fanger model. Also we have a meeting room PMD and PPD. You can see this is the office 01, office 02. So all the single rooms or spaces have now PMD and PPD data. We can analyze it later and we can see that which one is better or worse. We'll do the same process in each of the buildings and then we'll come back again. Now we have completed all the thermal comfort output variables in there and also simulated all of them. Now for one point I would like to focus here. As you can see that at the end, when we are putting the PMV and PPD and the daily temperatures, if you want, you can calculate in hourly. I am trying to calculate here in daily. It's up to you what you want to do. If you want to put it hourly, you just write here hourly and it will come with hourly data or monthly. So when we have done all of them, Now we are going to analyze that which model is giving us a better result in terms of electricity consumption and also heating and cooling energy demand. So to do that, first we are going to open a separate Excel file. So we have created the three different layouts with the same function, but now we are going to develop a comparison among the layouts to find the best energy efficient design. To do that, we are going to compare electricity consumption, cooling energy and heating energy in those three layouts. First we'll see how we can compare the electricity consumption data of the whole facility. So this one is electricity consumption, and first we'll copy the data from the file. So first we have building 1 in the browser, we simulated it. Now we'll go for the variables, and as you can see that we have different variables in here. If we just click there and put wrap text, and then so now it's easy to read which one we have here. So we need the electricity facility daily, so we'll copy the entire field here and we'll paste it in the new book. So here we have building 1, and if we paste it, this one we can put this name in here. Now we have the building 1 here. Now we can put the time in this side. To do that, we can go to the CSV file and we can just copy this date and time and paste it in this row. So now we have the building 1 option of all the dates. We'll create all three options like building 2 and building 3. We'll just make a boundary so that it will be easy to understand what we have here. So we'll go again and browse to select the building 2 option. We'll simulate it. Now we'll go to the variables again, and here again we have the same characteristics. We'll just wrap it, and then you can see here is the data. We'll just select it, copy it and paste here. So we can see that we have all the numbers in there for building 2. Now we'll go for building 3. To do that, we have to do the same, loading the building IDF file and then simulate it. We already have the 2 CSV files, and we are now creating the third CSV file. In case of the CSV files, you don't always have to go through the EP launch platform always. In the folder, if you go, as you can see that I will open the variables Now if you want to see the CSV files, you just have to go to the building 1 folder, and you can see here the building 1 CSV file is there. You can also open this and you will have the same data in there. So if we now see the building 3 option, and we have the daily electricity in there. So if we select it and paste it here, so now we have 3 of these data in that chart. Now we can see we have all 3 building data of the electricity consumption, and there this electricity consumption is basically from the equipments and the lighting. Now it's in joule. We have to convert this data into kilowatt hours, and to do that we'll first need to know the unit conversion value from joules to kilowatt. If we search in convert joule to kilowatt, we can see in Google we can find the conversion rate. Now we'll create another 1 joule equals to the number of kilowatt hour. Now we'll copy the same thing on the side so that we can have the kilowatt hour values in here. Now we'll delete all these numbers and we'll calculate in kilowatt hour. So first, this is the joule value of building 1 on January the 1st, and now I will multiply that with the kilowatt hour. Now if I put enter, we can see that it's in scientific value. We will convert that into numeric numbers in here, so it's 14.42. if we shift it on that side, we can see that it comes up with value. Why it happens? Because it goes to the building 2 value, but it also shifts the upper cell number and it doesn't have any number in there. So to do that, what we'll do, so that it doesn't have this error, we have to fix this second cell. To do that, we have to put a $sign in front of both of them, the row and the cell column number. And then if we do it now, see, now the cell in the red color is actually fixed, but the other cell is moving. So now we can go from here to the next one. Also you can see that it's moving, but this one is static. And now we can do it for all of them. So now we have the kilowatt hour value of the electricity of the whole facility, and if we plot this, all 3 options, we can see that, let's go up. So now we can see that the almost from all 3 values, the lowest one is building 3 option. Now we also need to see that what is the difference between among the buildings in terms of heating energy and cooling energy. So this sheet will name it electricity. Next one, we'll create another sheet for heating and cooling. For that, first we need to go to CSV1, use the building 1 CSV file. If we go a little shift here, we can see we have the cooling data and the heating data. So let's copy both of them. So now we are going to copy the cooling and heating data from the building 1. As you can see, first let's copy the date and time. Now we'll copy the cooling load. This is the cooling load. And you can copy the tree building option from the previous page. Okay, now we'll go to building 1, cooling load. One of the cooling loads, and just paste it here. It's not the cooling load, it's the district cooling daily consumption. On the other hand, we'll go for building 2, and we have to go for the cooling load here, cooling consumption. Then we'll go for building 3, and copy the cooling consumption here. Now we have all the 3 cooling data here, as you can see, and let's make that cooling demand into a joule area. Yes, first we can copy that. And then we can say enter. This value multiplies with the previous page. We had the same kilowatt hour value. Now we want to put this one into a static value, and if we just go that direction and put them into number and just continue that to the end, we have all the values we need. So this is the cooling facility, and this one is kilowatt hour. Now we can do the same with the heating facilities. To do that, we are going to do the same thing with the 3 buildings, and will come when we finish. So now we have the building 1, 2, 3 heating consumption data. So now we are going to make this joules data into a kilowatt hour data. To do that, we'll copy and paste them, and then we're going to delete the numbers here because we will calculate them with this value multiplied with the kilowatt hour, and now we know that how much energy it's going to consume. We have to make it static so that it doesn't move, and then if we just continue that direction, so there you go. So in all this analysis, we have done one thing first. First, we have bring the all building data in terms of cooling, heating, and electricity consumption, and we put it in comparison side by side. But the question is, here you can see there are lots of data because these are 365 days of data, and if we plot them, as you can see here, it's way too much to apprehend. Even if we plot them in a different characteristics, for example, let's say plot them in a bar chart, still these data are way too much to apprehend. So this is a good way to see that how the characteristics is changing, but this characteristics is not giving us a very conclusive idea. To do that, we can also try something else, like for example here we went with daily data. How about we can compare the monthly data? So if we compare the monthly data, it will be much more smaller in scale, and the charts are going to be much more readable. So let's make a comparison here. But in case of monthly data, you don't have to go long distance because it's already there. There is the monthly data just by the side. But the question is lots of cells are not checked in there. Like lots of cells are empty because this value is after it's in the 31st date of that month. So what we can do, we can make them a filter. So in case of filter, what comes if we click these two values and bring them into the filter, and then you can see there are two select arrows here where you can click it and there is a drop down box. Now at the bottom of the drop down box you'll see there is a blank. Just uncheck the blank and you'll see only 12 data are here. So let's do this. First we have building 1, and in case of building 1 we'll just select the dates, and when we are pasting them below the cooling here, cooling data, these all is still there in joules, so we'll just put them into this value. See, I copied them and paste. While I was pasting them, I said match destination formatting. If I put paste links, then it can go very different ways. For example, if I just say this, then it will have all the links in there. I don't need them. So just putting the paste option as a numerical just a value in there is much more better. Also now in case of building 1, because we have the building 1 option here, we can copy and paste them there also. Okay, now if we just go and copy them, for building 1 we have cooling data, copy and paste them here, and if we can just, yes, now we just have only 12 data here. We'll do the same for all the cooling of building 2 and 3, also in terms of heating and then we'll come back to analyze it. Now you can see that we have copied the data from those 3 files in here, and now we are going to convert it to the kilowatt hour values. Multiply with and we'll make it static. There you go. Now we are going to convert it to kilowatt hour. So now we can see all the data in there. Now it will be easy to compare them. Let's first compare the cooling data. In terms of cooling data, it's very much easily, we can see that the lowest amount of energy needed for cooling is in building 1. Also, if we go for heating, so in terms of heating, we can see the least amount of energy needed is for heating in building 3. So in terms of heating and cooling, we can see that the better option is to go for building 3, whereas if you consider cooling, which is not much more prevalent, is you have to go for building option 1. So here it is one solution it is giving to us. Now we can do the same here in terms of this option, electricity option. So let's do it again. We can go to the date and time option. We can copy these 12 values only, put there. We need another cell here. So and the value we are bringing in is the electricity facility, not just daily. We are going for monthly, and for monthly we have to go for electricity facility monthly, this one. So if we just copy it, and then we can go for building 1. So we have the monthly electricity consumption. Also for building 2, where is that monthly? Yes, there it is. And then we need just the building 3 and the facility. Now we can make this the kilowatt hour option. kilowatt hour, monthly data, copy the dates. You can put the name of the month actually also there. Now if we just click and multiply them with the unit conversion value and make them static, and then just copy all of them and make them number. And now we can compare the. Now you can see that the comparison of the electricity consumption is there, and in that comparison the lowest electricity consumption is coming from building 3. So if we take this chart and place all these 3 charts side by side, we can see in case of heating and electricity, which are the highest consuming areas, one of the highest, and the building 3 option is better than all 2 other options. In case of cooling, the building has higher cooling consumption. Other than that, the heating and electricity, the building 3 option is the better one. So we are going to work with building 3 in terms of when we look for increasing the thermal comfort, and also working with building shading devices or solar heat gain features. These passive cooling or passive design features will reduce the hopefully will reduce the energy consumption of that building in the future. But from this analysis we can see that the best option is to go for building 3. From the analysis you can see that building 3 has the best option in terms of heating and electricity here, other than building 1 and 2. And the building 3 option, as we know, that is the double story building design we had in our 3 options. And the windows here, as you can see, that they are totally without any shading, and the window to wall ratio here is 30%. Now we'll try to see that which window to wall ratio and which shading option can put more efficient building design, or can render a better solution for this building. So to do that, we'll work with some different options. So we created a separate sheet here. The objective now is to experiment with different fenestration options in the selected building 3, and see the energy efficiency output, so that we can elevate the energy efficiency of the building by choosing the best option. And for that we will see 2 experiments. Like, first of all, we will see that wall to window ratio, and second of all, by using a certain type of shading device, how we can change the energy efficiency of the building. Building 3 analysis, and here we'll try to see that we'll look for 4 options, which will be 30% wall to window ratio without any shading, 30% wall to window ratio with shadings, and with 60% wall to window ratio. And we will see that what is the energy consumption, cooling or heating output of this system. So to do that, first we are going to work with 30% window to wall ratio and shading. the default simulation we did was 32, actually had the same 30% window to wall ratio. If we go to the opening, we can see here, and it had no shading. So basically the building 3 simulation results are the result for 30% and without no shading. So we'll copy them from here and just paste them in there. In case of heating and cooling, there you go, this is the cooling and this is the heating. So we have the 3 options in joules and monthly data we have here. Now we are going to create another option, which is going to be with shading, 30% window to wall ratio and with shading. So we have that, and now to put the shading devices, we'll go for in shading and we'll click local shading. In local shading, first we'll work with we'll work with 0.5 projection louver. If we click it, it will be loaded, and if we go for the layout view, now we can see that all the windows have shading devices now, 4 of them altogether. We can, as you can see that in the here, and there are only 4 shading devices, and the width, the height of the windows are much more than the shading devices. So we'll create another one, which is going to be a lower option, but it will have 4 shading devices detailed. So we'll edit that and we'll put the name devices with 5 louvers, and we'll put 5 here, number of loop blades, and okay. So if we click it, it should be loaded. Yes. Now as we have it here, if we go to the layout, probably you'll see now that we have covered all the window height with the new louver system. Now if we go and export the data simulation, okay, we'll create a new file saying that building 03 with the option of 30%. We'll name the file 30% opening with shading. Now we'll save it, the IDF file, and if we open the IDF file, we'll see that in the bottom again all the data are there. We'll just get rid of the variables. We'll just keep the Fanger model PMV versus PPD data, and also the other data are there. And in this case, we can also look for the solar radiation file, solar gain and solar heat loss data also. For that we need to close this file, and then we need to go to EP launch, load the 30% shading file, and we need to run the simulation with the same London and Gatwick weather file, because we are trying all the simulations in the same weather file. we elevated the output variable, so it takes a little more time. And now if we go for the RDD values and search for heat gain, we can see that we have a hourly on average window heat gain and heat loss. Now we can copy these two, and if we open the file and go at the bottom and just paste it, then we'll have the heat gain and heat loss from the windows in there in watt. So as you can see, this data is coming in hourly. We'll put them into daily for analyzing a little less amount of data. You can go for hourly, or you can also work with special days like the winter design day or summer design days, or worst case scenarios in summer and winters, and also take regular dates of from the year and simulate it here. And we'll save it and then we'll close it. Now if we simulate now the same file, it should have the heat gain and heat loss data in there. If we go for the variables now you will see that we wrap the text, and there you go. So we have the heat gain and heat loss from all those different zones, like meeting room. Here we have the office 1 heat loss. Here we'll have office 2. So sorry, that's toilet. So all the options are here. And now we can go and make the other buildings options that we want to create. So minimize that. Now we are going to create 30%. We already created 30% with shading, and now we'll create 60% without shading. To do that, we have the IDF file of this one, and now we'll change the system. You can save the file, and you can make a copy of this file and save it as a building 03 60% unit to wall ratio. So we put building 03 and 60%, and then you can go to openings and convert this 30 to 60% and get rid of the local shading if it's checked on. So if we go to the layout, now you can see that you have bigger windows. And now if we export this data as simulation and save the data file, say in the run with the same run period, and then save the data file with building 360 IDF. As you can see at the end, now you can see that at the end we have some outputs that we don't need, so we'll get rid of them right now, and we'll save the file, close it. We have to go to EP launch and browse to find the 060 and simulate it. We're going to simulate and going to find the in the RDD file. We'll look for the heat gain and heat loss output variable from the windows. 0. And if we go to RDD and search for heat gain, you can see the total zone heat gain on average, zone average is there. Now copy that and open the text editor, go at the bottom, just paste it and save it. Now if we run it again, it should have the heat gain data in there. So we have created two of the options already. One is 30% shade wall to window ratio with shading, and another one is 60% without any shading. Now, excellent. If we open the variables, you'll see that we have the heat gain and heat loss options of the different zones in there. So we'll close it and then we'll minimize it, and we have to save this option as 60, but now we'll have shading. And now we'll save it, and we are going to go to openings, load the local shading. Now in case of local shading, if we put the 5 numbers of blades in the shading device option, you can see that there is a huge portion of the window which is not shaded with louvers if we are preferring louvers, and so that we have to create another one. So we'll click it. We have already created it in the same process. Go copy it and then edit it, and in there we put number 8 because it's almost the double of the size of 30%. So we put it in there on 8, and it should cover the whole area of the window. And if we go and in the layout, if we try to see, we didn't load it, sorry, we have to double click it, it will be loaded. Yes, if we go in layout, now you can see that all the windows are fully shaded. So now we are going to export the Energy Plus simulation file, and we'll do this for the same period. Now we'll save the file with the name 60 building 360 shading and save, and yes, we'll go at the end, get rid of all the extra output variables, save it, and then go to Energy Plus and browse 60 plus shading, simulate it. Yes, it should be finished very quickly, and then we'll have all the options we need in our hand. So now if we go to the variables, there should be, so when the simulation finished, we can go to RDD and look for heat gain. Found it. So we'll copy these two options and go to text editor at the bottom, paste them, and we can see the options here. We'll convert these to daily and save it and simulate it. So from our analysis we needed 4 of these options in terms of electricity, direct cooling and district cooling and district heating and demand in there. So we will now extract this data, plot in here, and then we will also look for other analysis variables to work with. So it's going on, it should be finished very quickly. Okay, so if we now open the variables, there you go, we have the heat gain of different zones in there alongside with the people object like PPD and PMV, and also other parameters like electricity demand and district heating and cooling demand also. So now we'll minimize it and we have the separate files. If we go in the folder, you can see that all the cases are built here, and now we are going to look for 30 without shading CSV. So if we first say with shading, we have the data. Now we'll look for the 30% wall to window ratio with shading, and if we just put it there, merge it, and then so first we need to see that what's the electricity demand, total electricity facility, and we are looking for monthly data. So first we are going to make it a filter and get rid of all the blanks. There you go. So this is the monthly electricity data from 30% and shading. We'll copy that and paste that here. So we have our 30% plus shading data in there. Also, if we look for another option which is 60 building and with 60, we'll open that one also. We'll do the same here, and we'll put a filter in there. There you go. So we have the monthly facility, and we'll copy this. As you can see, there is no change in the equipment and the electricity demand from equipment and lighting. So there is no change in there for these 3 options, and hopefully there will be no change in there from 60% opening shading. There we go. If we look for, first let's make it a filter, and there's the monthly and blank, and there you go. So we have the monthly data and there is probably no change, and there is no change in this number. So electricity, in case of when we change the shading devices, and so we can see that in this case there is no change if in terms of electricity from interior lighting and equipments when you change the wall to window ratio and shading devices. That's one point. Now we are going to look for options such as that what is the district cooling and district heating. So in case of district cooling, we have, it's a daily, we need monthly. There is the monthly data, and this is the another one. Okay, So we have the cooling data here. It is for 30 and shading. We'll just put it here, and if we just go for the second option, which is going to be here, the monthly data, and if we just put it here, that is 60% and shading, I hope, without shading. Yes, now we have the option of 60 and shading. So if we just go a little further, it should be here. There you go. Select it, copy and paste it here. So we can see that there is a change in the number. So when we are changing the feature of the fenestration, it is affecting the cooling. We'll see how it's affecting. First, let's copy the heating data, and then we'll see. There's the heating data for 30 and shading. Then we have the 60 without shading, 60% without shading, and then we'll look for 60% with shading. So now we have all the data from the heating also. Let's check that how it is changing. So if we put these options according to there, we can see that there is a change, and 30% and shading is reducing the cooling load, heating load, 30% without shading, and the energy demand, when you make it 60% and shading, it's higher than others. So to make it much more understandable, let's put this into kilowatt hour. To do that, we don't need this because there is no change, but still will. Now we'll just put the number here, and we'll go to electricity and select this. So we have that, and multiply with this number. So we'll first make it static. There you go. And the options, and we can make them numbers. If we just copy that and paste that, you can see that it shifted the whole cell here, and we have the same number. Now we can just look for the kilowatt option of heating, and there is the option of cooling. So when we change the building features, we can see that the lowest cooling demand is in 30% plus shading. Now you can see that in terms of cooling and heating energy demand, here in the 30% window to wall ratio and shading provides the lowest cooling demand, whereas the lowest energy demand in terms of heating is 30% minus shading, whereas the 30% plus shading is quite closer. As you can see, this one, these two numbers are quite close in terms of the heating energy demand. So we can take the 30% window to wall ratio plus shading of 5 louver blades, or 0.5 meter louver blades. So now we can see that this is the option much better for our building fenestration and envelope for reducing energy demand. Now we are going to see that in building 3 design options, how these features of changing the shading device and window tool ratio affect the PMV by PPD, or the thermal comfort of this building. So first, for that we will see the most commonly used place, which is the populous area of the office building is the open office area. We'll see that how much thermal comfort is ensured in there with these options. So for that we'll see, like, open office is our target, and we will work with different options. But first we have to make 2 rooms, because it will have 2 parameters, PMV and PPD. So okay, we have everything here. Now we are going to bring this layer would be for PMV and PPD. So first we have to get rid of this one, because we need that. We're going to see the daily PMV versus PPD, and we are looking for open office. So office 1, open office, there you go. So now we'll see that what's the result we have from open office. In daily in PMV, and we also have a monthly PMV, but we'll work with daily PMV here and PPD of the open office. So if we just select all of them, this is 30 with shading, so it will come here, and the name, we'll copy that from there. We don't need it, just PPD, and the PPD would be so we have that, and now PPD is going to be there. So we'll copy it and paste it there. We'll do the same for 30% and without shading, 60% without shading, and 60% with shading, and then we'll come back to see the analysis. We have created the table with all the PMV versus PPD and PMV and PPD data in the daily basis from all the 4 options we are trying. Now we'll plot them by using selecting the first 30% window to wall ratio without any shading option, and then we will go to insert and scatter plot. So this is the thermal comfort. So let's see what can we do here. So now we have other 4 options, and so now we have the 30% minus shading, PMV versus PPD. This is PMV and this is PPD. Now we will add other 3 options here by selecting select data. So first just edit this, put the name in there. Okay, now we'll add the other 2 options. For first shading plus, and then we have this PMV, and then we have y-axis PPD. Okay, again we can add another series where we'll have that one, and PMV in the x-axis, and in the y-axis we have PPD. Excellent. And we go and add another one, plus shading option of 60% window to wall ratio, and just select the PMV and select the PPD one. So we have the PMV versus PPD here, and as you can see that if we just click them in terms of sorry, just trying to put the axis values in there, titles. So this is the PPD, this is PMV. So this is the thermal comfort option we have now. So if we change, as you can see that if we just analyze the data, it's hard to analyze all together. So if we do it separately, then it's better, but also we can do it like this, so that we can see that which one is better option. So we can just copy and paste this thermal comfort data, get rid of the 60% shading one, 20, and this one. So now we have developed the thermal comfort analysis for the 4 options we have, and we can see that the scatter plot is showing that PPD versus PMV value for 30% window to wall ratio plus shading is performing best than that of others, because most of the data, the uncomfortable range are 60 are less in these characteristics, and also in terms of satisfied data, like it's not crossing 0.5 in term if you consider the hot part, and in terms of cold it is quite similar to 1 and 4, but because of the concentration of data in this section higher, we can work with 30% and shading, and we can see by changing any material or other properties how we can ensure better thermal comfort. So if I choose these graphs, you can see that the cooling demand in option 2, 30% plus shading, is lowest in cooling energy demand. In case of heating energy demand, it's not the lowest. The building option 1 is the lowest, but it's quite closer. and also the thermal comfort. And from the thermal comfort point of view, the option 2 is better than other 3 options. So we are going to choose option 2, which is 30% window to wall ratio, and with shadings, blinds, louver shadings, 0.5 meter louver shading, and we can do further studies on it by changing any material, and then we can also see that how it affects the solar heat gain or the thermal comfort level, also how it can increase the efficiency by decreasing the heating energy demand or cooling energy demand more what we have here. Thank you.